Hello and welcome in today's video. In today's video, we're going to look at the arming codes. And this is the definition of an arming codes, saying that arming codes are a family of linear error correcting codes that can detect up to 2 bits errors or correct 1 bit errors. Arming codes. So what is their purpose? Their main purpose is number 1, detect and correct single bit errors. Number 2, improve the reliability of data transmission and storage. So my interest is in the construction of these arming code. How can we be able to construct them? So we've been having challenges here and there from the student side, whereby they do not understand how to construct these codes. So let D denote the number of data bits and R denote the number of redundant bits. These are what we call the parity bits. For example, if the 7-4 code, this is split into, the 7 is split into 2, that is 4 and 3, where 4 will represent the data bits, that is the data itself, and 3 will represent the parity bits. So, when you come to this, you have now the bit positions. Because we say that in total we have 7 bits in that particular arming code. So we are saying that position number 1, that is, this is split into these positions. That is, you have position number 1, position number 2, all the way to position number 7. So position number 1 is represented by this type of the bit which you are calling the P1. So for example of a parity bit. Position number 2 is represented by P2, which is parity bit 2. Position number 3 is represented by D1, which is now the data, or part of the data. Position number 4 is this particular type, which is P4, another parity bit. Position number 5 is D2, which is the data bit, the same with position number 6 and number 7. So in this particular case, P1 will check these positions. That is position number 1, position number 3, position number 5, position number 6, 7. Parity bit 2 will check position number 2, position number 3, position number 6, position number 7 in that particular code word. P3, it will check position number 4, position number 5, position number 6 and position number 7. So with that, why do P1 check these particular digits or this particular position and not another position, P2 as well, and the P3? I want you to consider this, where this is the position number 1, position number 2, position number 3, position number 4, position number 5, number 6, and number 7. So in this particular case, these 3 data bits or binary bits will be corresponding to these different positions in this particular table that we have here, which is 1 all the way to 7. So I want you to check these 3 binary bits that are ending with the number 1 here. Like for example, that one is ending with a 1, that one is ending with a 1, that one is ending with a 1, that one is ending with a 1. So in this case, that is the reason that we are saying that this parity bit 1, after arranging them in this particular position, which is correspond to these 3 binary bits, those values or positions that are ending with 1 here, they are the ones that are associated with this particular parity bit 1. And you can see these are 3, 5, 7. So that's why we are saying that 1 or P1 checks or parity bit 1. It will check this position, that is position number 1, position number 3, position number 7, 5, position number 7. So when you go to parity bit 2, we now consider this particular position, that is the second position from this end. So the ones that are ending with 1, it is that one, you have that one, you have that one, and that one. That is the reason we are saying that parity bit 2, it will check position 2, position 3, position 6 and position 7. That is what we've indicated in 2, 3, 6, 7. The other one, it is parity bit 3. So now in this particular case, we consider this position number 3. So the ones that are ending with 1, it is that one in that position, this one, and that one. That's why we are saying that this parity bit 3, it checks positions number 4, positions number 5, position number 6, and position number 7. So how can we be able to construct a simple chord? Now with this particular position, suppose you are given this particular data. If it is the data is having 4 bits. So this is the data that you are given and you are supposed to encode it so that you can send it to somebody or to the receiver. So if you are given such a case, you need to know these important statements here. That for me to be able to construct my P1, I need to add D4. I need to add D1 plus D2 plus D4. For me to be able to get my P2, which is parity B2, I need to add D1 plus D3 plus D4. For me to be able to add or to get P4, I need to add D2 plus D3 plus D4. And those values are here, will be given in your data code. So for example, in this particular case, this is what we have. We have position 1, or we have parity bit number 1. This is how they follow one another. We have D1, we have P4, and from there we have D2, D3, D4. In total you can see we have 1, 2, 3, 4, 5, 6, 7. So from this particular data of data that is given, we will transmit. So this one will represent our D1. The 0, the first one will represent our D2. This 0 will represent our D3. And lastly, this will be our D4. So from these calculations here, we need to fill in this particular position, this position, out of this given information that we have here. So for example, in this case, my P1 will be given by, we have D1 plus D2 plus D4, which is going to give us what is the value of D1 in this particular table. It is 1 plus the value of D2 is 0 and the value of D4 is 0. So this will give us what? 1. So meaning that in this particular position we have 1. That is the parity bit 1 will be equal to 1. So how about parity bit 2? This is given by what? D1 plus D3 plus D4. D1 plus D3 plus D4. So these circles mean just the sum of these two values. So which will be given by what? What is our D1 in this particular case? It is 1 and the others are 0. So this will be plus 0 plus 0, which is going to give us 1. Now this means that in this position we need to put what? 1. So the next one, it is P4. That is parity bit number 4. And this is given by what? D2 plus D3 plus D4, which is going to give us what? So what is our D2? What is our D3? What is our D4? All of them are 0, so this will be 0 plus 0 plus 0, which is going to give us 0. Meaning that in this particular position we have 0. So now our code word is equals to D2 plus D3 plus D4, which is equals to 0 plus 0 plus 0. For those values in our table here, they are 0, 0 and 0. So this message is encoded as so now you read it from this particular side. So now our data that is transmitted, it will be 1, 0, or 1, 1, sorry. It will be 1, 1, 1. Then we have 0, 0, 0, 0. And you can see in total we have 1, 2, 3, 4, 5, 6, 7. So that is the message that is sent to the receiver. So let us look at the next example. And the next example, we are told to encode the 4-bit data, which is equals to 1, 0, 0, 1, 0, 1, 1. How do you encode that data? So we use the same procedure, but in this particular case, we need to construct our table, which is as follows. But we have P1, we have P2 just like the previous one here. We have D1, we have parity number 4, we have D2, D3, lastly D4. So once again, this will be our D1, this will be our D2, this will be our D3, and this will be our D4. So we should check the positions in this particular table here that we are given. So this will be 1, that is correspond to that one. Our D2 will be equal to 0. Our D3 will be equal to 1, and our D4 will be equal to 1. So next it is we construct or we fill in these positions P1, P2, P4, which are now the parity bits. Now we said from the previous example that P1, it is given by D1 plus D2 plus D4. So meaning that in our case here, shall take 1 plus our D2 which is 0 plus our D4 which is 1. You can see this is giving us a total of 2. But in binary numbers we deal with zeros and 1. So meaning that this one will be expressed in binary form as a remainder upon division by 2. So when you take 2 divided by 2, this will give us 1 here. That we have 2 down there, and the remainder is equals to 0. So it is this remainder that you're interested in. That is what should be put here. So in this case, we just conclude that 1 plus 0 plus 1, it is equals to 0. So why? It is because that when we normally add 1 plus 1, you get a 2. But now in this particular case, we are picking the remainder upon division by 2. So what is 2 divided by 2? Because how many times 1? Because of 2 then. The remainder here is 0. So we put a 0 here instead of 2. So now meaning that now in this particular position we put a 0. So parity bit 2, it is given by what? It is given by D1 plus D3 plus D4. Now you have these values, you know what is your D1 from here, you know what is your D3 from here, you know what is your D4 here. So once again, this will be equal to 1 plus 1 plus 1. This is going to give us 1. Now some of you will be asking, why are we getting this 1? So normally when you add 1 plus 1 plus 1, you get 3. So but now we are taking these values more 2. That is when you divide 3 by 2, it is going to give us what? It goes how many times? 1 because of 2 here. And the remainder will be equal to 1. So it is this remainder that we put here. That is, we conclude that 1 plus 1 is equals to 1. So this position we put 1 there. Next it is parity bit 4. Parity bit 4, it is given by D2 plus D3 plus D4. Like that one. But you know what is your D2? D2 is given as already given. It is 0. D3 is 1. And the D4 is 1. So you add these, you get a 0. But once again, this will be normally 1 plus 0 plus 1 plus 1, which is equals to 2. And now when you divide 2 by 2, the remainder is 0. So we are interested in this remainder. That is basically how we convert decimal numbers into binary numbers. So once again we put a 0 there. So this means that our message is encoded as, so now you read from this side, 0 1 1 0. Hope you can be able to see this clearly. 0 1 1 0, and we have 0 1 1. So that is our message that you're going to transmit to the receiver. Suppose now you are given this particular message, and suppose the 7-bit received code is received code, it is 0 1 1 1 0 1 1. So how can you be able to detect? That is number one. And if you're able to detect the error, what position is that particular error, and are you able to correct that particular error? So that is what we'll be looking at this particular example. So once again you come up with your table again, which is P1, P2. From P2 you go to D1. D1 you go to P4. We have D2, D3. Lastly, D4. So in this particular case, unlike the other one, which is about the encoding, these positions are all given, and it is in this code word that is here. So meaning that your first bit, which is P1, is 0. The second one is 1, followed by 1, 1 again, 0, 1 1. So to the properties that are associated with P1 odd in this particular case, because we say that the P1 is always given by what? D1 plus D2 plus D4. The other one, it is P2, it is given by what? D1 plus D3 plus D4. Lastly, it is P3, which is given by D2 plus D3 plus D4. So when you look at this code word that you are given, this is given, this is given, this is given. Also this P1 is given. So the implication here is that 1 should be equal to, or should be equal to, the implication here should be, you take now your P1, and our P1 in this case it is 0. And this 0 should be given by our D1, which is 1, plus our D2, which is 0, plus our D4, which is 1. So in this case, when you add up this, they should give us 0. And if it is giving us 0, and that is what we have as our parity bit 1, then it means that that position is correct. Meaning that these values D1, D2, and D4, they are also correct. So you need to move on and check the other. Because you now see here that 1 plus 0 plus 1, it is equals to 2, and the remainder upon division by 2 is 0. This is actually our parity bit 1. So meaning that that position is okay. What we put as our parity bit 1 is okay. Because the problem could be when you are transmitting this message, you read it to somebody and they hear different things. Like now you can read the code is 0 1 1 1 0 1 0 or 1 1. But instead of that person hearing 1, which is at the last position there, he hears that particular position as 0. So already the error has occurred. So it's about you to sit down and try to check where the error is. So when you look at position number 2 or parity bit number 2, this is given as 1. These values, when you sum them according to this code word odd, they'll be able to give us 1, which is our parity bit 1. So this means that this will be 1 plus our D3, which is 1, plus our D4, which is 1. And if we check this is 1 plus 1 plus 1, which is 3. And 3, when you divide by 2, the remainder is 1. So which is okay, and actually that was our parity bit 2. So it means that D1, D3, D4, they are okay. So you now need to proceed and check whether there is another error. That is the parity bit 4 or 3. Now this is 4, not 3. Parity bit 4 is given as follows. So parity bit 4, what is our D2? Our D2 is what? 0 plus our D3 is 1 plus our D4 is 1. That should actually give us our parity bit 4, which is 1. And when we check this already, it is an error. So when you add 0 plus 1, it is giving us 2. It is giving us 2. So 2 mod 2, or the remainder of 2 upon division by 2, you get remainder 0. So meaning that actually this should be 0. I repeat, what we are having here as our parity bit 4 is equals to 1. But now when you add these positions, D2, D3, D4, they are not giving us 1. They are giving us 0 instead. So meaning that there is an error. And the error is in this particular position, which is position number 4. That is P4. But now through inspection, you realize that D1 plus, or in the first parity here, D1 plus D2 plus D4, it gave us a correct thing. So there is no way this would be an error, or D1 would be an error, D2 would be an error, and D4 would be an error. So that one you nullify. You can have a check like this, or maybe we can just inspect directly. So when you look at P2, P2 was also correct. You got the correct thing, and it was given by D1 plus D3 plus D4. So meaning that you have exhausted all the cases here. Because now if it is D2 that has an error, there is no way it is having an error here and it never had an error here. If it is D3, there is no way it will be having an error here and it was correct here. If it is D4, there is no way it will have an error here and it was correct here. So meaning that the only thing that has a problem, it is this parity bit 4. So instead of having 1 here, we replace with 0. And now you go back to your code word, and whenever you have this P4 as 1, you replace with 0. And now the correct code is, and you write it, which is 0 1 1 0 0 1 1. That is our correct code word, and we have identified the error together in the position where that particular error is and corrected it. It was in this particular parity bit 4. That is how we correct these errors. For example, we received a code which is equals to 1 1 1 1 1 0 0. So once again you come up with a table. In this case I make the table detailed, whereby we have the position. The position is 1 2 3 4 5 6. Lastly we have 7. And these are associated with this bit type. First one, it is P1 followed by P2. This will be our D1. This will be our P4. This will be our D2, D3, and lastly D4. So in this case now it is now the values in our code word. Example, for this first position it corresponds, this is second, third, fourth, continuing that one. So this is 1 1 1 1 1 0 0. So it is to check whether these holds, that is P1, because you know that P1 is always given by D1 plus D2 plus D4. Is it correct? So you take your values of D1 here. This would imply that if our P1 here is 1, it should be the case, should you add D1 plus D2 plus D4. So meaning that this would be what? 1, because our D1 here is 1. Our D2, which is here, it is 1. We add 1 plus our D4. Our D4 is 0. we add 0 there. So you can see this is giving us what? When you add 1 plus 1 plus 0, it is going to give us 0. Because normally it is the addition of these three values. Thereby 1 plus 1 plus 0, it is going to give us 2. But you're interested in the remainder once again upon division by 2. But you can see here, what we add as a P1 is equals to 1. But what we are getting actually it is what? 0. So meaning that there is an error here. Why? This is because 1 is not equal to 0. So meaning that either the error is in D1, D2, D4, or P1. But we need to check the others so that we'll be able to eliminate some of the cases. Out of these combinations, because we are adding these values, we realize that there are those that are exempted. When you look at P2, in P2 it is going to be D1 plus D3 plus D4. Implying that what is in our P2? It is 1, which is given by what? Our D1, which is 1, plus D3, which is 0, plus D4, which is 0. Or D4 is 0. So meaning that 1 plus 0 plus 0, it is equals to 1. And in this case, our parity B2 is equals to 1. So it means that D1 is exempted, D3 is exempted, and also D4 is exempted. Because if they are wrong, then they could have given us the wrong values in this particular addition. So there is no way the error will be in D1, D3, and D4. So we exempt those of them. So we look at P3, or P4, sorry. And the P4 is given by, so P4 is always given by D2 plus D3 plus D4, which implies that our P4, which is here, is 1, will be equal to our D3 or D2 plus D3 plus D4. So this one, we have 1 plus 0 plus 0. But what is 1 plus 0 plus 0? It is going to give us 1. And actually in our P4, we are having it as a 1. So meaning that there is no way this error will be in D2, D3, or D4. Because if it is an error, or they have an error, then we could have gotten this value incorrect, or we could have gotten the incorrect value of this. So meaning that this is correct. This one is correct. So the error is only here. But now, since D1 is correct here, it's giving us a correct value of P2. There is no way to give us or it will be wrong here. So if D2 is giving us a correct value here, there is no way it will be wrong here. We go to D4. D4 in P2, that is the second line here. It is also giving us a correct thing. So meaning that if it is incorrect, or if it was correct here, then there is no way it will be correct here. I repeat, if our D4 was correct here, then it means that also here it is correct. If our D1 is correct here, also here it is correct. If our D2 is correct here, also here it is correct. So meaning that the only value that has an issue, it is this P1. So we have to change it. Because now the others you can see they are correct. So meaning that we have to flip this, we change this value from 1 to 0. Now you will notice that everything or the code word will be corrected. So now the corrected code word is, so this will be 0 1 1 1 1 0 0. That is 0 1 1 1 1 0 0. That is the correct code word. So in that case you are able to correct, and you've seen that the error it is in this parity bit 1. So initially they've given it as 1, but we detected the error and corrected, so it's supposed to be 0. So this is our correct code 1. So in the next example, we are going to look at a case whereby the error is in the data bits, not the parity bits. In this case, we have this code that the transmitted code is as follows. So once again, we come up with the table. But we have the position. The positions are 1, 2, 3, 4, 5, 6, 7. By here we have the bit type. The bit type you have P1, you have P2, you have D1, you have P4, you have D2, D3, and lastly D4. So your code is as follows, whereby you have now the value now. P1 is 0 from the code word there. P2 is 1. D1 is 0. P4 is 1. P5 is 1. P4 is 1. D2 is 1. D3 is 0. And D4 is 0. So we see where the error is. So once again, we know that P1 is associated with D1 plus D2 plus D4. So, but what is our P1 here? P1 is given as 0. So meaning that you do add, if it is a correct thing, the correct code word, we add D1 plus D2 plus D4, it should give us 0. So what is our D1? D1 is equal 0. Our D2 is 1. And our D4 is 0. So you can see 0 plus 1 plus 0 is not equal to 0. So in this case, there is an error here. For the first case, our P2 is given by what? D1 plus D3 plus D4, which implies that what is our P2? P2 is given as 1. They should be given by what? Our D1, whereby our D1 is 0 plus our D3 is 0 plus our D4 is 0. I repeat, D1 is 0, D3 is 0, and the D4 is 0. So when you add up this, are you getting 1? No. So meaning that once again you have an error here. But if it was correct, they should have been 0. So our P3, or P4, sorry, our P4, that is parity bit number 4, is given by D2 plus D3 plus D4, which implies that what is our P4 here? Our P4 is given as 1, so meaning that 1 will be equal to our D2, by our D2 is equals to 1, plus our D3 which is equal to 0, plus our D4 which is equal to 0. And you can see this is correct, because 1 plus 0 is equals to 1. So this is correct. So in this case we do some comparison here and there. By we have D2 plus D3 plus D4. They are giving us the correct thing. So meaning that it will be also correct in this one, in this one. So if it is correct here, there is no way it will be wrong here. So meaning that this D2 here is correct. So D3 is correct here, so meaning that it is also correct here. D4 is correct here, meaning that it is also correct here and also here. So of course D2 you have said that it is correct, and you can see we have exhausted everything in the data cell. So we've seen that this is giving us an error here and another error here. So but D2 is correct, D3 is correct, all these three equations. D4 is also correct. So the challenge that we have here is that we are not sure whether this D1 is correct. But for the others, which is D1, which is D2, D3 and D4, they are correct. Meaning that if we can try to change this D1 from its original value, will it be able to give us a correct thing? I repeat, if D2, D3, D4, they are correct here, it means that they are also correct in this equation and this equation. So meaning that in the first equation, the problem is either in D1 or P1. In the second equation, the problem is either in D1 or P2. You can see in either way the two are common. So the common problem is D1, meaning that we need to vary this from 0 to 1. And if we vary it from 0 to 1, will this be correct? Because this will be now 1 plus 1 plus 0, which is equal to 0, which is correct. If we vary D1 here from 0 to 1, will it give us a correct thing? Yes, because 1 plus 0 plus 0 is going to give us 1, which is what we have here, which is correct. So our error is in D1. So the error is D1. So what do? We change D1 from, we change our D1 from 0 to 1. Now the corrected code word is, so now it will be 0, 1, 1, 1, 1, 0, 0. So we have 1, 2, 3, 4, 1, 2, 3, 4. The others are 0. So this is the corrected code word. So it detected the error. So the error is not always in the parity bits, it can also be in the data bits themselves. So thank you for watching this video. So make sure that you subscribe, and if you want to support the channel, you can also support it. So if you have a suggestion on more areas that you want me to elaborate or expound, you can always do a suggestion on the comments that are down there. So in the comment section, you can be able to make a recommendation on the videos that you want me to present for you. Otherwise, thank you.